All right, let's talk about 3.5 now. It has to do with polynomial division. So let's talk about polynomial long division. There's two types. There's polynomial long division, and then there's something we're going to get into called synthetic division, which is easier. And I know that you guys are seeing this huge brick of text right now and maybe freaking out that it looks complicated, but it really isn't. It's just mathematics has to say things in a very precise way. So let's look at the division algorithm, which says that for a polynomial dividend f of x and a non-zero polynomial divisor d of x, and this is the important part, where the degree of d of x is less than or equal to the degree of f of x. That means the thing on the bottom has to be of lesser or equal degree than the top. Then there exist unique polynomials q of x and r of x, that's the quotient and the remainder, respectively, such that f of x is d of x times q of x plus r of x. And the good news is you already have been doing this forever. This is literally just what factoring is, except in a much bigger way. But let's take a look at an example and figure out exactly what this all means. Example, it says find the quotient of x squared plus 8x plus 16 over x plus 4. So we want to do this division and figure out exactly how it works. And you can see, actually, it's been typed up for you. That's what it's going to look like. So I want to do it again, except show you what all that looks like. And if that looks like long division to you, like the kind of division that you're used to doing back in 4th and 5th grade, it's because it is. So let's take a look at this. So here's how this is going to look. You're going to take x plus 4, the thing on the bottom. You're going to take x plus 4, and you're going to divide it into, x squared plus 8x plus 16. So the thing to keep in mind here, when you're doing this sort of thing, is there's a step process. And it's the same 3-step process that you are always used to doing back when we originally divided numbers way back in elementary school. So let's talk about how to go about doing this sort of thing. So what we're going to do is we're going to say, here's how this works. It works off of the leading degreed term here, so x. So the question is, how many times does x go into x squared? Or another way of thinking of it is, what is x squared divided by x? Well, x squared divided by x, if you came out here and wrote this down, x squared divided by x, well, that's clearly just x. So we're just going to write down x and write it down above the x term. This should start looking familiar. Now, if you remember, after you do this basic division, the next step is normally multiplication, then subtraction, and then you do it over and over and over. So that's exactly what we're going to do. We're going to do x times x plus 4, and we're going to write it down here. So x times x is x squared. Okay? X times 4 is 4x. Of course, it was x times a plus 4, so it's plus 4x. And then we're going to subtract, and this is the important part, you're going to subtract the whole term. So you'll notice over here, what's happened when I typed this up was the negative has been distributed. That's the important thing to remember, is you just subtract each term if you want to, or just subtract the whole thing and remember to distribute it. So do the math. X squared minus x squared is 0, it cancels. And then this is 8x, right here, this is 8x minus 4x. So 8x minus 4x, minus because it's minus a positive, 8x minus 4x is 4x. That's where this came from. Now, you'll notice this plus 16, that came from just bringing it down. It's the same thing that you're used to. So bring down the plus 16. And now you're ready to do it again. This is why it's called an algorithm. It's just a thing that you repeat over and over until it's done. So again, you go through this process again. You say, okay, what is the leading term here? What is 4x divided by x? That's what you're asking. What is 4x divided by x? Well, 4x divided by x is a positive 4. Write that above here. Now, 4 times x is 4x. 4 times 4, doing this multiplication over here, this 4 times 4 is 16, positive 16, and then we're going to subtract this. Clearly that's going to be 0. They're the same thing. So that means that our remainder is 0. Neat. So we've done the entire long division thing. And honestly, the only way to get good at this is just to do a bunch of them. The good news is there's a much easier way to do it that we're going to get to in a minute, though this is something that will help you out in Cal 2 when and if you get there, so we're going to go ahead and go over it. So let's label the parts of what this is. What was the d of x, the q of x, and the r of x? What was all of that stuff? So let's label this pretty simply. I'll do it over here because it's a little bit more obvious and easy to read, but this is your r of x, your remainder. So that's your r of x, all right? Your d of x, your divisor, is the thing that you divided by, so this is your d of x. And then your q of x was the thing that you got out, your quotient. So technically, if I asked you to find the quotient, it's that. That's the quotient. So what we can do is we can write it like this. So we can write this example down here as f of x equals the d of x, which was x plus 4, times the q of x, which was also x plus 4. So that was the q of x, that was the d of x, and then plus the r of x, which we'll do in white. Well, that's just 0. So we could write this as x plus 4 times x plus 4. That is, we could write the original thing, this guy right here, as x plus 4 times x plus 4, which you'll notice means that we could have just factored it and canceled a term, and we would have been done. However, this is the way to guarantee that you can always do these, because it doesn't always evenly divide. And we'll see that in the next example. So here we're asked to find the quotient of x squared plus 3x plus 5 divided by x minus 2. And you can see over on the left that that's been done. But we're going to give it another shot. So we're going to divide x minus 2 into x squared plus 3x plus 5. And you don't have to wait for me to say this, but now would be a great time for you to pause the video and give this a shot yourself. It would always be a good time to pause the video and see where you get stuck, so that if you do get stuck, you can just be like, hey, and then press play and watch me go through it and be like, oh, that's what he was doing. Try to do these problems along with me instead of just watching me do them, and you're going to get a lot more out of this class. But the process is the same as always. All we're going to do here is we're just going to say, okay, x squared divided by x is x. So put x up here. That's it. Now, x, this x up here, times this x here is x squared. This x up here times this minus 2 is minus 2x. Okay? And then we're going to subtract this whole thing. Just like that. All right? So remember, you have to distribute in this negative. That's why this is a minus x squared plus 2x, because this minus a negative is plus a positive. All right? Keep that in mind. So x squared minus x squared is 0. 3x plus 2x, because it's minus a negative, is 5x. And if you want to go ahead and write it like this, just change the signs on everything when you do it, go ahead. Do the multiplication up top, do the x times the x, and then change the sign to a minus x squared. Do the x times a minus 2 and change the sign to a positive 2x. If you want to do that, go for it. Some professors teach it that way. I teach it different. So you get a 5x here, and you're going to need to bring down your 5 term. It's a plus 5 up there, so it's a plus 5 down here. All right? I'm going to change colors for the next part. Now, we do the exact same thing. We say x goes into this x, goes into 5x, right? That is, 5x divided by x is positive 5, so we're going to write positive 5 up here. And then we're going to do the multiplication again. 5 times x is 5x. 5 times negative 2 is negative 10. And then we're going to subtract this whole thing. All right? So now that we've subtracted the whole thing, remember this is minus 5x plus a 10. So minus 5x minus 5x is 0. And then this will be 5 plus 10 is 15. Why is it plus 10? Don't get confused, guys. It is minus a negative. And you might want to go ahead and deal with that. Just go ahead and distribute this in and then deal with it if you want to. If you want to come back up here before you do this step, and you want to say, you know what, just make that positive, make that negative, and make that positive. Just change the signs on everything. And then basically just ignore this and then do the math. 5x minus 5x is 0. 5 plus 10 is 15, but you should have never written the 0 to start with, so you just write 15 here. If you want to do it that way and that's easier for you, that's fine with me. It doesn't matter. But remember, this is your remainder. And it's not 15x, it's just 15. This is your remainder, all right? This is your quotient, x plus 5. Okay. This is your divisor, x minus 2. And what we're saying is that this thing, x squared plus 3x plus 5, this, we're saying that x squared plus 3x plus 5 equals, well, x minus 2 times x plus 5 plus the remainder, 15. If you don't believe me, which you might not, you might be like, that seems like wizardry. Well, look, I'm just going to do the math on this. Let's FOIL this out. X times x is x squared. X times plus 5 is plus 5x. This is minus 2x minus 10. Minus 2x minus 10. And then it's still got the plus 15 from the original thing on here. So if you just do this math real quick, you'll see pretty plainly that you get x squared minus 5x plus 5x minus 2x is a plus 3x. And then minus 10 plus 15 is plus 5. And look here, that is exactly this. They're the same thing. So we figured out a way to write a polynomial as a factored form plus something else. The something else being the remainder. Incredibly useful. Because this tells me that this function is going to behave exactly like this factored form. That is, it has zeros at positive 2 and negative 5, except we've just lifted it 15 up off the axis. That's useful. That's incredibly useful to look at. And it becomes very useful when you want to cancel things or do other kind of manipulations on this. Hey, this is cool. And it'll always work. So, we've had linear terms here so far. That's x to the first on the bottom. Let's see what happens when these get a little bit more spicy. Alright, so this one looks weirder. And that's because it's being divided by an x squared term on the bottom. So let's see if we can figure out how this one works. So we want to divide x squared minus 1 into x cubed, okay, minus 6x squared. And here's the thing that wasn't done over here, but we're going to plug in a plus 0x term right into it. So go ahead and fill that in. Notice in the original term that there was no x term, so then there were 0 of those. So make sure that you plug those in. And it'll just help you keep track of everything. So, it's the exact same steps as always. You say, all right, x cubed divided by x squared. That is, I'm literally doing this. X cubed divided by x squared. Well, that's x to the 3 minus 2, which is just x. So that's just x. So we're going to go put the x above where the x goes, which is why it's important that you fill in with the 0x part. All right? So that's x. And then you just do the multiplication like normal. Just make sure to put the corresponding parts underneath the parts that you actually need to subtract. This is the hard thing to keep track of, but it's not terribly difficult, really. X times x squared is x cubed. So let's put that underneath the x cubed term. All right? Now, I'm going to do this again, but in white. X times minus 1 is minus x. I'm going to put the minus x over here. So I'm going to put the minus 1x over here. Now here's the important part to remember. Nothing is going to be taken away from this term. So it's just going to be brought down, basically. It can be brought down through the problem, or you can come down here in this part of the problem and put in your 0x squared term if you want to. Fill in any missing terms as zeros on this if you want to. Or just bring it down. In fact, that's what we mean by bring it down, if you just want to do it like that. Either way, whatever works for you, I'm going to prefer to write the plus 0x part. And then remember, that we are subtracting here. Okay? So this is x cubed minus x cubed. That's 0. This is minus 6x squared minus 0x squared. So that's just minus 6x squared. This is actually what you've always been doing when you just bring a term down. And then it's going to be plus 0x minus a negative x. So that's going to be, if you want to change the signs again, you can do that. You can say this is plus, this is a minus, this is a minus, this is a plus. So 0x plus x is plus x. Like that. All right? Now, all we're going to do is once we get to the next step, always bring down your next term, plus 3. And then we're just going to do the exact same thing again. And it's a lot to think of, but it's not the worst thing in the universe. So all that we're going to do now, and I'm going to do this in a completely different color. Let's do this in a nice, I don't know, let's do this peach color. I like that. So let's look at this. Let's say here, we're going to say negative 6x squared. We're going to say negative 6x squared. Let's actually do it in the color I said I was going to do it in. Negative 6x squared divides into x squared how many times? That is, we're doing the problem negative 6x squared over x squared. Well, that's clearly just minus 6. So we're going to say then minus 6 up here. Minus 6. Now we're going to do all of the math with minus 6. So we're going to say, again, we're going to say minus 6 times x squared is minus 6x squared. So minus 6x squared. And then we're going to do it one last time. We're going to say, okay, minus 6 times minus 1 is plus 6. So we're going to write plus 6 right here. We're going to fill in our missing terms because the term's missing. So we're going to say plus 0x. And now we're going to remember that we are subtracting all of this. That's the important part. Okay, which is why this looks different over here. This has got everything distributed through. This has got everything distributed through. So, if you want to go ahead and do the distribution, that's fine. Make this positive, make this positive, make this negative, make this negative, if you want to. If you want to just go ahead and distribute that through and do the math. All right. So this is negative 6x squared plus 6x squared. Or, if you don't want to do all this distribution, you can think of it as minus 6x squared minus a negative 6x squared. Well, it's a number minus itself, so it's 0. We don't write it. And then it's positive x minus 0x. Well, that's still just positive x, right? Positive x minus 0x is still just x. Nothing changes there. So the last thing is, this is 3 minus 6. 3 minus 6 is negative 3. Okay, so what we're going to get then is a remainder of x minus 3. Now, how do we know that we're done? How do we know that there isn't another step? Well, you've brought down everything for one. But on top of that, what would the next step be normally? It would be take this number right here, this x, the number that was here, and then divide it by this number, x squared. Notice that the degree on this term is now less than the degree on this term that we've been dividing by. That's how you know you're done. Because this is a 1, and this is a 2, and 1 is less than 2. So you know that you're done. So this is now your remainder. So your remainder is, in fact, a polynomial this time. Which means that we can write the original dividend here, the thing that we were dividing by, x cubed minus 6x squared plus 3. We can write it as, let me do this in a nice purple. We can write it as this times this plus this. What's this? It's x squared minus 1 times x minus 6 plus x minus 3. And if you want to go ahead and do the foiling and everything and check to make sure that that's true, I guarantee you it is. Go for it. It'll work out exactly like it's supposed to. So that's what we did. Now that is a more complicated example than I actually expect you to know how to do. However, the only difference on this is you've got to bring in these 0x and 0x squared terms. Make sure that you fill in the literal blanks like we did over here, instead of leaving gaps. Now that's a lot of colors, and that's a lot of stuff going on, but it's division. It's long division. Think back to 4th grade when you first learned long division, and it was overwhelming then too. But I have good news for you, because we have this thing called synthetic division, and it makes your whole world so much easier. So there's 2 things that you need to know for synthetic division, because I haven't actually written out what synthetic division is here. It is a shortcut to do this, but there's 2 caveats. And you should write these caveats down. The caveats are this. The number in front of this divisor here has to be 1. Positive 1. Has to be positive 1. Now there's ways around that, and we'll get to that later. But it has to be positive 1. And here's the second thing that we can't get around. The power, the degree down here, also has to be 1. So there needs to be 1s both as the coefficient and as the degree of your denominator. Otherwise, this doesn't work. Synthetic division will not work for an x squared, x cubed, whatever term in the bottom, or a polynomial in the bottom. Nor will it work if the leading coefficient down here in this bottom polynomial is anything other than positive 1. Now, there's a way around that, and we'll get to that later, but this has to be of degree 1 in the denominator, otherwise it isn't going to work. Good news is that's most of what I want you to do, is this. So I'm going to walk you through the process now, and we're going to take a look at this. So here's how this works. You're going to make yourself a big L here, okay? And what you're going to do is you're going to take the coefficients, assuming that this is 1 and this is 1, then you're good to go. So you can start using this. We're going to take the coefficients, that is 1, positive 8, and 16, positive 16. And we're going to say they're all there, right? All of the terms are there. The square term's there, the first term's there, the 0th term's there. And we're just going to write them out. So the first coefficient was 1, so we write a 1 here. Okay. The second coefficient was positive 8, so we write a positive 8. The third coefficient was 16, so we write a 16. Then what we do is we take this number on the bottom and we change its sign. So this was a positive 4, so we're going to write negative 4. And I'm going to write it up here because this is what I like to do normally. They wrote it down here when I typeset this. It was just easier to typeset it this way. But I'm going to write negative 4 here. And then we just start doing the same sort of thing over and over and over and over and over. We've got one more step to finish this up. We're going to bring down this 1, and we're going to get started. So if you remember back to just a few minutes ago when we were doing polynomial long division the long way, it's just a process. Do the division, do the subtraction, and then do the math, and then bring down numbers and repeat. And it was just the same thing over and over and over and over until we were done, no matter what. This is just getting rid of all of the x squareds and x's and everything in there and working with just the coefficients because that's all that matters. So here's how this pattern works. What we're going to do is we're going to take this number, always this number, and we're going to multiply it by this number down here. So we're going to say 4, okay, times, you don't have to write the times when you're doing it, nor do you have to draw the arrows. I'm just doing that to show you this. So negative 4 times positive 1 is negative 4. Okay? Then you're going to add these two terms together, not subtract. And remember, back to just a minute ago, look back in your notes. We're always doing that minus a negative thing, right? There was that weird thing where we had to constantly keep track of the minus and negative, and it was always flipping things around. So here we just add. We just get rid of all that BS, and we just add. So 8 plus a negative 4 is a positive 4. Then you do this exact same thing again. I'll do it in this green color. So we're going to take negative 4, okay, and we're going to multiply it by 4. And we're going to put it right here. Negative 4 times positive 4 is negative 16. 16 plus negative 16 is 0. And then I like to come over here and put a box around this. That is, if I were finishing this problem up over here, the actual answer would end up looking like this. So the way that this is going to work is, this was a second degree polynomial. You can see up here, this was a second degree polynomial. If you take just the leading terms here, you take this x squared and you divide it by this x, you know that the thing you're going to get out is going to be an x to the first polynomial. Overall, that's what you're going to get. And that's what you're going to get over here as well. So let's just look over here for just a second, because that's kind of messy with a lot of colors and a lot of stuff going on. The way that I read this is your x term. This is your x to the first term. This is your x to the 0th term. X to the 0th term. And this is your remainder, which is always going to be a number when you're doing synthetic division. So how you write this is then, you write this as 1x to the first plus, because it's positive, 4x to the 0 plus your r of x term. That is, this is just x plus 4, because x to the 0 is just 1, plus 0. And that's it. We're done. Now, we'll see how to deal with this r of x a little better when we actually get something that isn't 0. But what this means is that this here is your quotient. It's just x plus 4. Which means that you could have done this entire thing as, well, this is x plus 4. That is, notice this is the exact same problem that we did the first time. Look at what we got when we originally did this, back forever ago. We did indeed get x plus 4 as our quotient, the thing on top of the actual whole division thing. Awesome. Let's do another one, and this will become a little more clear to you. So in this one, we're asked to divide x minus 2 into x squared plus 3x plus 5. So first, we can use synthetic division because this is a linear term with a positive 1 in front of it. So we're good to go on that. So we just write. Make a little box. And then we write our coefficients. And notice that everything here, there's this to the first, there's to the first, there's to the second. Here's your x to the 0 term. So we're just going to write all this out. Let's write out the coefficients now. So the coefficient on this is 1, positive 3, positive 5. So we're going to write 1, 3, 5, like that. We take the negative of this number, 2, write it right there. We bring down our 1, and that's the setup. That's always the setup. So now let's just do some math, I guess. So we do 2 times 1. 2 times 1 is 2. 3 plus 2 is 5. We add them together. And then we do 2 times 5 is 10. 5 plus 10 is 15. That's the remainder. That's how we got all that. Okay? I'm going to rewind and do that again. I did 2 times 1 is 2. And then 3 plus 2 is 5. I then did 2 times 5 is 10. And 5 plus 10 is 15. Okay? What does that tell us? That tells us that our quotient is precisely, we have a remainder of 15, the number 15, and that our quotient is, this is your linear term, because this was a second degree polynomial divided by a first degree polynomial, so this will be a linear thing. So this is 1x to the first plus 5x to the 0, right? And then your remainder's tacked on. So we just write it as plus your remainder. Over your divisor, x minus 2. Because it was left over and hasn't been divided. So that's a way to write this. We didn't have to write it in the previous example, the division thing, because it was 0 and it wouldn't have mattered anyway. So this is how this ends up working. So we can say that x squared plus 3x plus 5 over x minus 2 can be written as x plus 5 plus 15 over x minus 2. Or, if you just want to multiply both sides of this by x minus 2, think about it. Multiply both sides by x minus 2. It'll cancel over here on the left, and you'll get this. And then on the right, I'm going to multiply x plus 5 times x minus 2, like this, plus, and then when you multiply this term, the remainder, by the x minus 2, all that's left is the 15. And this should look a little bit more familiar. So what it's saying is you can write the numerator as what you divided by, this term here, what you divided by, times what you got, plus your remainder. That's the division algorithm. Cool. Let's do one more, and then you can do a bunch of practice on this. We're asked to divide 3x minus 1 into x cubed minus 6x squared plus 3. And there's two things in this problem that can trip you up. Also, notice that it hasn't already been typed out. So if you want to give this a shot, go for it. But it's probably going to be a little difficult for you, because there's two tricks in this that I'm trying to get you with. So first off, notice that this is a 3 and not a 1. So you can't do this as is. So we actually have to do some manipulation first. The second thing we need to check on is to make sure that this divisor here is 1, that the degree is 1. And it is. Cool. So we can do synthetic division, but we got to do some stuff first. So we got to get rid of this 3. So let's think for just a second about this. Let's write this down. Got to do some math over here first. X cubed minus 6x squared plus 3. Okay, over 3x minus 1. So I want to get rid of that 3. So what I'm going to do to get rid of that 3 is I'm going to multiply everything on the bottom by 1 over 3. And if I multiply everything on the bottom by 1 over 3, you better believe I've got to multiply everything on top by 1 over 3 as well. So what this is going to turn into then is 1/3 times x cubed minus 6 over 3 times x squared plus 3 over 3 over 1/3 times 3x is 3 over 3 times x minus 1/3. Let's go through and do all the math. That is 1/3 x cubed minus 6 over 3 is just 2 x squared plus 1 over 1x minus 1/3. So this thing written right here is exactly the same as our original problem. Except now there's a 1 in front of this x like we wanted. That's why we multiplied by 1/3. You will always just multiply by the reciprocal of whatever this is. And if it's negative, you're going to want to multiply by the negative reciprocal. What you're trying to do is make this number positive 1. So multiply by top and bottom of everything, every term in the entire thing, by what you need to make that positive 1. So if this number in here were a negative 3, then we would have multiplied top and bottom by negative 1/3. But it wasn't, so we didn't. All right? So now that we've got this, we can actually set up and do the synthetic division. Neat. So let's set up and actually do the synthetic division. But first, let me move this over for you for just a second so that we actually have some space here to work with. So, and there's no problem in rewriting this again. So this is 1/3, and maybe you want to stand it up like this. 1/3 x cubed minus, this was 2x squared plus 1 over x minus 1/3. So now we're going to go ahead and do the synthetic division. We'll do it right here. Why not? So here's the couple things you need to watch out for. First off, the number that goes outside is positive 1/3. Positive 1/3, like that. Yes, you can have fractions out here. Now, we need to list the coefficient of every term. So the coefficient of the x cubed term is 1/3. So we'll write 1/3 right here. Okay? The coefficient of the x squared term, the next one in line, is minus 2. So we write minus 2 right here. However, notice that there is no x to the 0 term over here. It's missing. So you have to write a 0 because you were missing the x term. This is the equivalent of bringing things down or writing those missing terms in like we did in a previous problem. And then 1 was the constant term. In general, if the degree of your numerator is n, you're going to have n plus 1 terms. So this is 3 on top. So you better have 4 things in this list right here. A good way to check. So to finish the algorithm setup, we just bring down a 1/3, and now we just start with some horrendous math. And it's not the hardest thing in the universe to do, but man, is it tedious. But we can do it. So let's just do the math now. So we're going to do 1/3 times 1/3 is 1/9. Okay? 1/9. And then we're going to do minus 2 plus 1/9. Minus 2 plus 1/9. That's just, well, that's minus 18/9 plus a 9th. Like that. So that's minus 17/9. Neat. Minus 17/9. Resist the temptation to use a calculator on this. Next, and this is just going to get more horrendous as we go along, 1/3 times negative 17/9 is going to be negative 17 over, and then 3 times 9 is 27. 0 plus negative 17/27 is negative 17/27. Okay, let's continue again. Oh boy. 1/3 times negative 17/27. Well, 1 times negative 17 is negative 17 again. And 3 times 27 is 81. And 1, which is 81 over 81, we can do it up here in white. 1, which is 81 over 81, minus 17 over 81, is 81 minus 20 is 61. 3 back is 64. It's 64 over 81. And that's your remainder. 64 over 81 is your remainder. Awesome. Ugh! You hate it, I hate it, but that's your answer. So, this was a 3rd degree polynomial divided by a 1st degree polynomial, so you should get a 2nd degree polynomial out. That is, 3 minus 1 is 2, meaning this is your x squared term. This is your x to the first term, this is your constant, and this is your remainder. So, we're going to end up writing this as, then, 1/3 x squared, okay, minus, because it's a negative term, minus 17/9 x, okay, minus 17 over 27, okay, plus, because this is positive, plus the remainder, 64 over 81, over the thing that we divided by. Not this thing that we divided by, though. This thing that we divided by. This thing right here. X minus 1/3. Because that's what we divided by. X minus 1/3. That's why there's a 1/3 here. Okay? And that's an answer. But it's horrendous, and I hate it. So what we're going to do is scroll down to give me some more room here, and we're going to simplify this down a little bit. And then we'll be done. And you might notice that the problem here is we're dealing with, over here, we don't actually have the original thing that we divided by. So what I want now is to change it back. We had to change it so we could do the problem, and now we need to change it back. So what we're going to do is take just the remainder, because it's the only way that this is legal, and we're going to multiply it by 1. We could multiply all the other terms by 1 in the same sort of way if you wanted to. It's just going to make them look more horrendous. So what we're going to do is we want to get rid of this minus 1/3 on the bottom. So we're just going to multiply by 3 over 3. And that'll get rid of the 1/3 on the bottom. So this thing is going to look like, when we get done with it, 1/3 x squared minus 17/9 x minus 17/27, okay, plus 64 times 3 over 81 is the same thing as 64 times 3 over 81, and 3 over 81 is just that 27 term again. So this is going to be 64 27ths over 3x minus 1. And you'll notice that 3x minus 1, this 3x minus 1, is exactly what we divided by originally, which is what we're trying to get. Okay? Now, if this math here is confusing you, this fraction math here is confusing you, let me show you what I did again. What I did on the top was 64 over 81 times 3. That's what I did on the top. This is exactly the same thing as, well, we can just divide the 3 into the 81. That is, we can write 64 times 3 over 81. And then 3 over 81 is just 1 over 27. So this is 64 times 1 over 27. Like that, which is just 64 over 27. Okay? On the bottom, what we did was x minus 1/3 times 3. I just distributed into 3. 3x minus, and then 1/3 of 3 is 1. That's it. So it's going to be this, which is what was on top, divided by this. The reason that we wanted it like that was because that's what we originally divided it by. That is, you could write this original top term here, this x cubed, you could write this original top term here, I'll do it up here, as x cubed minus 6x squared plus 3. That is, that can be written as what we divided by, 3x minus 1, okay, times all of this garbage, plus 64/27. So it's 1/3 x squared minus 17/9. 1/3 x squared minus 17/9 x plus, or minus 17/27. Oh boy. All right. Plus, in the end, that little extra bit, that 64 over 27 bit. 64 over 27. And you may see why this wasn't taught in Algebra 2. That is nasty. Rewriting it like this is something we'll get better at in Cal 2 when we get to it. For now, the thing that I need you to be able to do is this right here, this synthetic division. This is by far, without a doubt, the absolute worst kind of problem I could give you. This is the worst that it gets. A lot of the ones that you'll see in your practice are a lot easier than this. However, that is the end. If you have any questions, of course, you're always welcome to ask me in class, and we'll see you in the next video.